Hello. Is it audible to all of you now? Is it audible to all of you? Is it audible to all of you now? Is it audible? Audible? Okay, fine. So read the question and try to solve. So try to solve the question now. So for the truncated cone as shown in the figure, calculate the torque required if the cone is rotated at 200 rpm. Okay, this is the cone is given to you. So this one is called as the top radius. Okay, this one is called as the bottom radius, and the 9 centimeter and 16 centimeter is given to you, and the angle between these two surface is given 60 degree to you. Okay, and the thickness is 2 millimeter is given to us. So it is asking to find out what is the torque. What is the torque required? It is asking. Okay, what is the torque required? Okay, what is the torque required? It is asking. So in next figure, you see how can solve. So this, suppose this one is so this one is my top radius and this one is my bottom radius. This one is my bottom radius and this one is my top radius. Okay, suppose in order to find out, suppose this, you just imagine this one, this cone is rotating, this cone is rotating about this axis, this cone is rotating about this axis, and there is in this gap the oil will be there. In this gap the oil is there. Okay, imagine the oil is there in this gap. So what is happening? If it is rotating about this axis and around this oil will be there, then oil will provide a resistance to this motion. Okay, oil will provide a viscous resistance. Okay, so where the resistance will offer? The resistance will offer on the surface of the cone. Okay, on the surface of the cone the resistance will offer. So in order to find out the torque, what is the thing? We know torque will be equal to force into the perpendicular distance. Okay, perpendicular distance. What is this force? This force is called as resistance force, or this one is called as viscous force. Okay, this viscous force will be equal to shear stress into the area on which this force is acting. The area on which the force is acting, that area is nothing but is called as surface area. Okay, that area and surface. What is the shear stress? Shear stress will be equal to mu, according to Newton's law of viscosity, mu into this B divided by this thickness. The thickness will be this one, the thickness. Okay, this is thickness T. Okay, now we have to choose a very small strip. Now we have to choose very small strip from this one, very small strip. In order to find out the surface area of this cone, I have to choose a very small strip. Okay, very small strip I have to choose. This is my strip. Okay, this one is my strip. This is my strip. Okay, this is my strip. Okay, so now I am magnifying here. This is my strip. This is my strip, and this one is my axis of the body. This one on axis of the rotation. Axis of rotation. Okay, so around this is rotating. Okay, suppose this one has a radius. This strip has a radius from this axis. Suppose this has a radius from this axis. Suppose this is my radius. Okay, suppose this radius will be nothing but, suppose this one will be r, small r. Okay, this will be my small r. Okay, and this inclined distance, suppose this inclined distance, you see this inclined distance. Okay, suppose this one is my dl. Okay, and if you draw a perpendicular to this one, if you join this corner if you join, suppose this one, this distance is, suppose this distance, this one is dr. Okay, now just I am magnifying this one here. I am magnifying this one right over here. So the right over here, this one is dr, and this one is my dl, and this angle nothing but is called theta, because this angle, imagine this one, suppose you extend this one, so this angle is theta. Okay, if this angle will be theta, definitely this angle will also be theta. So sin theta will be how much? Sin theta will be how much here? Sin theta will be equal to, this will be equal to dr by this one will be dl. Okay, first we have to find out the surface area. If you find out surface area, 90% problem will be solved. Okay, now what is the surface area? What is the surface area? Surface area will be equal to, if it is rotating about the axis, it will take a shape of circle. If you take a shape of circle, what is this circle surface area? This is 2 pi r into this one is dl. Okay, 2 pi r into dl. What is this 2 pi r into dl is how much? This is dr by this is sin theta. Now you find out the small elemental area strip. This is dA. Okay, now can you find out the shear stress? Okay, now if you find out what is this resistance for df will be equal to tau into this dA. Okay, what is this tau? This is mu into b divided by this thickness t. What is this dA? This is 2 pi r into this is dr by this one is sin theta. Okay, now if you find out the torque dt, what is the dt? This is df into this r, because the shear stress is acting on the surface. What is the perpendicular distance? The perpendicular distance nothing but this is called as small r. Imagine that, imagine. So you can write down this mu, b is how much? B is, I can, this is r omega divided by this is t, and this is 2 pi r into this is dr by sin theta into this is r. Okay, so what is this dt is coming? So dt if you solve this one, how much it is coming? This dt is coming out to be 2 pi, okay, mu omega divided by this one is t sin theta, okay, into this one is rq dr. Okay, rq dr. So in order to find out the total torque, you have to integrate this one 0 to t. So you have to integrate from here, from this r bottom radius to r top radius. Okay, now you integrate this one. This is 2 pi mu omega divided by this is t sine theta into this is r4 to the power by 4. So from this limit is from this r bottom to r top. Now find out this one. Now find out what is this coming out to be. The total torque loss or the total torque required will be equal to this is 2 pi mu omega divided by this is t sine theta into this one is r t to the power 4 by 4 minus r bottom to the power 4 by this one is 4. Okay, if we again solve this one, this torque will be equal to pi mu omega divided by this is 2t sine theta into this is r top to the power 4 minus r bottom to the power 4. Okay, so this is the expression for this is the torque required. This is the torque required, or this is the torque loss due to the viscosity of the oil. Okay, so this is the formula you have to remember. So what you have to do, just you have to remember one thing, this torque will be equal to what is the resistance which is offered by this oil, that is called shear resistance, because the shear force which acts tangential to the surface, this df into the perpendicular distance, because if you imagine this is the small elemental area on this one. Okay, the df is acting, what is this radius? This radius is r, this radius is r. Okay, so the perpendicular distance will be this is df into r. Okay, df into r. What is this df? Df I can find out, this is tau into this is dA into this is r. Okay, what is this tau? Tau we can find out, tau dA is 2 pi r into this dl into this is r. So this is the basic thing. So you have to go from step by step. First you have to find out what is the torque df. First, next you have df is tau into surface area, then surface area you have to find out. Only one thing is surface area. If you can find out, the 90% problem will be solved. So if the the radius at the top will be given to you, at the radius of the bottom will be given to you, this can you able to find out this one? Okay, omega is what? Omega is angular velocity. This is 2 pi n divided by this is 60. Okay, n is the revolution per second will be given, number of revolution per second. Okay, omega you can find out. Okay, t is the thickness, everything is given, theta will given to you. So can you find out the torque? So this is a basic formula in a GATE. Directly they will ask the question for this one. So this is the remember. Okay, so thank you. So there is a problem in internet connection earlier, so now I think it is solved. So tomorrow there will be no problem will be there. So thank you all. So do you have any doubt? You can ask me. Do you have a doubt? Ask me the doubt. Do you have any doubt? Anybody has any doubt? Ask me. class hoga, but 10 minutes there will be concept will be there, because now the trend is changed. You have to solve the problem and then you have to learn the concept. Okay, if you see the problem and you think, and then you could understand the topic. Okay, first you understand the problem clearly, visualize the problem, then you solve the problem, then the concept will be very good. Okay, so this problem is nothing, this is a classroom, this is a book problem is not there, this is a real problem. Okay, this is a problem at your home. Imagine that form, you take a bucket of water and rotate with a hand. Okay, imagine the shear stress, how it is acting on your hand, how it is the torque, how much required. Imagine all this thing, then your concept will be built up. Okay, do you have any doubt on this problem? Only here in this problem you have to find out the area, surface area, because the stress, when that solid cone is rotating about this oil, the coil is giving a resistance onto the surface. Okay, only you have to find out the surface area of this cone. Okay, only integrate you have to do. Surface area if you can find out, 90% thing will be over. The derivation is very not at all. You just take a pen and paper, you draw the solve this derivation, you can do it as easily. I will let you know when the class will be there. Do you have any doubt on this one? Okay, fine. Tomorrow I will let you know when the class will be there. So thank you all.